In the last few videos, you have seen how Glue can be used as a discovery tool and a metadata repository. We can use the Glue crawler, which discovers the metadata and then stores it in the data catalog. That is one part of Glue. Then we have the second part in which Glue can be used as an ETL job, and we can run Spark job using PySpark and Scala using serverless. And I had already told you in the Lambda video that serverless is actually serverless for users, but not for AWS. AWS has to have infrastructure to run the compute also. Same is the case with Glue. When we say it is a serverless ETL job, it means that it is serverless for us users, not for AWS. Typically, the ETL jobs run like this. We have different data sources. The extraction happens from the data sources. Then the transformation is done using distributed compute framework like Spark, and then the output is stored in data targets. Now, in case of Spark, you have seen that we use a Spark cluster. We have been using a standalone cluster using our laptop. You can use an EMR cluster also, EMR serverless or EMR EC2, wherein we can mention the driver and the worker nodes or the compute nodes in EMR. And Spark creates the drivers and the executors in the worker nodes itself. Similarly, to run Spark in Glue, we have to have workers, and those are known as Glue workers. We mention the number of Glue workers in the Glue console itself, and then Glue automatically either scales it up or scales it down. Now, when I say workers, you already know that it contains driver and one or more executors. We do not have to provide the number of executors here like we did in case of Spark standalone cluster or EMR. We just provide the number of workers, and the executors would be scaled automatically by Glue. Driver would only be one. The executors would be scaled out. And the processing unit that is used by Glue is termed as DPU or data processing unit. This is a billing construct of AWS. If we use Glue, the pricing is based on DPU or data processing unit. And one DPU is equivalent to 16 GB of RAM and 4 vCPUs. This is the compute capacity which is given to a single DPU. Then we provide number of workers. Now, how workers and DPU play out together. There are different types of workers, and Glue gives us information what is the amount of RAM and the number of CPUs each worker has. Depending on the number of CPUs and the amount of RAM, we can calculate the number of DPUs that an individual worker would get. As I already mentioned, the workers are automatically scaled by Glue. We do not have to mention any maximum number or the scalability parameters. It is handled by Glue internally. And the scaling would be basically increasing the number of executors. The number of driver would always be one. And as Glue ETL runs PySpark job, we have to connect to different data sources and data targets. That's why we have to use IAM role with the Glue ETL job, because the sources and targets would be native AWS sources. And then we can use a VPC using Glue connections that I have already shown you. So let me show you these parameters before running the ETL job or before running a Spark job in Glue. Now in Glue, the second component, that is data integration in ETL, there are various options of ETL jobs. If I click on ETL jobs, there are three options: Visual ETL, Notebook, and Script Editor. Either I select Visual ETL or Script Editor or Notebook for that matter, it will ask you the engine that I want to run a Glue on. So it can be a Spark engine or a Python shell. So Glue also supports Python shell also. And then we can upload the script if you have written the Glue script and upload it in S3, or else you can start from fresh. So this is the script. I'll talk about it later on, but the job information or the serverless or the infrastructure information would be provided in the job details. Here you provide the name of the job, then the IAM role. In our case, it would be 3IAM Glue data catalog role, because that contains the administrative access and the pass role permission also. Then you have the type. It is either Spark or Spark streaming. So as I told you that we can use both batch processing and stream processing in Glue. So if you're using Spark streaming, then Glue would keep on running continuously. If you use batch processing, it would run only once. Then we have Glue versions. Now, depending on the Glue version, we can see what Spark version is provided. The latest one in Mumbai region is Glue 5, which supports Spark version 3.5 with Scala version 2 and Python version 3. Then we have the worker type. So you see there are different types of workers here. Starting from 1x to 8x, there are other workers also which are available in North Virginia region, but in Mumbai region, these are the only 4 worker types. G1X contains 4 vCPU and 16 GB of RAM, which means that it is a single DPU. 2X would contain 2 DPUs with 8 vCPU and 32 GB of RAM. 4X would contain 4 DPUs, and G8X would contain 8 DPUs or data processing units. I can select 1X, and then we have options of automatically scaling the number of workers. You should always enable it, because using this, Glue can actually optimize the cost. And then we mention the number of workers, the maximum number of workers. Let's say I mention it to be 25, then Glue will never create more than 25 G1X worker or 25 DPUs, because G1X is equivalent to 1 DPU. Then you have something called generate job insights, which can be used to provide insights by Glue how to optimize a job. Either you can select it or deselect it. Then you have something called job bookmark. I'll come back to this when I talk about the ETL jobs. Then you have job queue running, flex execution, which can be used to reduce the cost further by using spare capacity. You can provide the number of retries, which can be used to execute the job multiple times in case of a failure. I'm mentioning here as 0. Then you can mention the timeout, after which the Glue job would be terminated if it does not complete within that particular time. By default, it is 8 hours, and we can of course change it. Then you have some advanced properties here. If we write the code and upload it in S3, you can provide the location or the path of the script. We can enable job metrics, observability metrics, and Spark UI. This is the same Spark UI that we have talked in our Spark session. Now, instead of storing it in our laptop, it will be stored in a S3 location, just like EMR. And this is the S3 location where the UI logs would be stored, and based on this, reading these files, the Spark UI would be shown to us from Glue. Then there are some configuration for Spark UI logging and monitoring, and also concurrency. Concurrency means that what is the maximum number of parallel jobs that you can run from this Glue job. So what is the maximum number of jobs that you can run parallelly? That's what it is. You can mention 1, 2, or 10, etc. And if you run more than that, then of course there would be an error. Then there are some other configurations that are needed, and connections is something which is used by Glue, and would need this connection if you are using Aurora. If you are not using Aurora, if you are using S3, then we do not need to provide any Glue connection. But if you are using Aurora, Redshift, RDS, DynamoDB, or anything of that sort, we need to provide a connection. Also, we can provide additional Python libraries and dependent jars needed for Spark. We can mention additional Python modules also. Let's say I have PyMySQL. So we'll have to provide the additional module or the PyMySQL module path here. I'll show you that when I run the ETL job. And then you have job parameters, which are associated with the resource, not with Spark, but with the resource. So these are the options that you can provide, or the infrastructural options that you can provide. Once it is created, nothing else is needed. Glue would automatically scale up and scale down the number of workers to a maximum of 25 that I have mentioned here. This is how we create the execution environment for Glue ETL jobs, which is serverless.